Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.4, Problem 5. This is Section 15.4, Problem 5. We have the definite integral of the square root of x dx from 4 to 1. So before I can actually solve the integral, I have to rewrite it in a little different notation. To solve an integral with a square root, I have to replace it with an exponent of 1/2. So let me rewrite this as the definite integral from 4 to 1 of x to the 1/2 dx. Now I can solve that integral. Step 1 of a 4-step process is solve the integral. So now this 1/2, that fractional exponent, I'm going to have 1 over the previous exponent plus 1. So 1 over 1/2 plus 1, x to the previous exponent plus 1, so 1/2 plus 1. So now to deal with that fraction instead of 1/2 plus 1, let me write the 1 as a 2 over 2. That's still a 1. 2 over 2 is just basically a funny looking 1, but now I have it written with a common denominator. So 1 over 1/2 plus 2/2 will be 1 over 3/2. X to the 1/2 plus 2/2, again, common denominator will be 3/2. And I can simplify that a little further. When I have a fraction in the denominator, what you're supposed to do is flip it or invert it and multiply times the top. So as I invert the 3 over 2, it would invert to a 2 over 3, times the top would be 2 over 3 times 1. So I have 2/3 x to the 3/2. That's the answer for the integral. Again, there is a plus c in there for plus constant, but on the final step it would cancel anyway, so I never really bother to write it. So the notation I use now that I finished step 1, I put a long vertical line to the right of my answer for the integral, and I put my limits of integration on it, a 4 for the upper limit and a 1 for the lower limit. So the next part of the process, step 2, I'm going to put in the upper limit of integration for my variable and solve for it. So I have 2/3 instead of x to the 3/2, 4 to the 3/2. Well, that fractional exponent's kind of weird. So the way you deal with that, you have a couple options. What you could do with your calculator is go 2/3 4, use your exponent button, and put in an exponent of 1.5, and you'll get an answer. You can use parentheses too, just to make sure your calculator will do it in the correct order. If you don't have a calculator handy, a different option is to put your fractional exponent back into a root type of notation. So you have the denominator being a 2, means the index of the root is a 2 or a square root. And the numerator of the fraction is still what power. So you have 2/3 the square root of 4 cubed. And you can either do the root first and then the exponent, or the exponent first, then the root. Either way, you're going to get 8. So if you do the square root of 4, you get 2, and then 2 to the third. 2 to the third is 8. Or you could do 4 cubed first. 4 times 4 times 4 again is 64, and then you do the square root. It's the square root of 64. You still get 8. Either way, you're going to have 2/3 times 8. Now, you're multiplying a fraction times a whole number. So the way I deal with this is I think of the 8 as an 8 over 1. And now when you multiply your fractions, top times top, 2 times 8 is 16. Bottom times bottom, 3 times 1 is 3. So that's the answer for step 2. I put in the upper limit of integration for my answer to the integral. Step 3, put in the lower limit. So I'm going to do 2/3 x to the 3/2 becomes 2/3 1 to the 3/2. Well, 1 to the 3/2 is way easier than 4 to the 3/2 that we had to do. 1 to any exponent like this, fractional or not, 1 to whatever exponent, it's just going to be 1. Then times the 2/3 in front, 1 times 2/3 is 2/3. So putting in the lower limit of integration is much easier. 0 also goes in very easily. So now the last step, step 4, is subtract the answer from the upper limit minus the answer for the lower limit, the step 2 answer minus the step 3 answer. Unfortunately, I already have a nice common denominator. So I'm going to go 16/3 from step 2 minus 2/3 from step 3. And now 16 minus 2, I have 14 over my common denominator of 3, 14 thirds. And you can convert that to a mixed number if you want. It's almost 5. So if I had 15 over 3, that would reduce to 5. So you could also write 4 and 2 thirds is the same as 14 thirds. Either form you prefer is okay.